In this lesson, I'd like to briefly run you through the causes and types of tides that we see on Earth. What may surprise you is that tides are not actually caused by the wind. Waves might be caused by the wind at the water's surface, but tides are actually caused by the gravity of the moon and the sun, the gravitational forces pulling on the Earth. Even though the sun is much larger and in general has a much greater gravity pull than the moon, because of the distance between both of these celestial objects and the Earth, the moon actually has the greatest influence simply because it is closer. The sun has a much stronger gravity, but it's so far away that that gravity pull does not compare to what the moon can do, which is nearby. Okay, let's take a look at this diagram down below. Here's our moon sitting here. Now, of course, this is not to scale. The moon is about 1/6 the size of Earth, and it's way farther away than you would imagine here. But this kind of gives you the idea. The moon, because of its mass, has a gravity pull, and it actually, if you look at where A is, it actually is pulling on the water, which is closest to it, which pulls the water out. Then it pulls on the Earth, but not quite as much because the water is closer. And then it also pulls on the water that is farthest away from the Earth, but has a very weak pull over here on B. When it pulls on the water here, you can see that it actually forms, in general, a much higher ocean level. Whereas, because it's pulling this water, you see a lower ocean level up towards the poles in this particular picture. Then the Earth gets pulled over. So the tidal bulge, we call it, on this side of the Earth, on the A side, the side that's on the same side as the moon, we would call that a high tide. And then when the moon pulls on the Earth itself, the Earth actually pulls away from the water, and that also causes a high tide on the opposite side of the Earth from the moon, on the B side here. So high tide over here because the moon is pulling on the water, and then a high tide on the opposite side because the moon is also pulling on the Earth, and the Earth gets pulled away from the oceans underneath. So high tides here, low tides towards the pole in this particular diagram. Now, as the Earth rotates past the moon, so we can see the Earth is rotating counterclockwise every 24 hours. As it rotates past the moon, you'll actually see that when it's right in line with the moon, you'll always have a high tide facing the moon. But when the moon moves to its next location a day later, you can see that in the dotted lines here, that the tide has followed the moon. So if I am person A, and I'm facing the moon right now, I'm going to go through my normal rotation, a 24-hour day. And so I might start off in high tide, then I'd experience a low tide, another high tide, another low tide, and I'd come back to a high tide because this would have shifted to over here. I'd be in the B position by the time I got back around with the moon moving as well. Okay, so we know then that you probably experience, as you're spinning on the Earth, again, this is the North Pole, so we're looking straight down on top of the Earth. As we are spinning on the Earth, we are actually going through 2 high tides a day, on average, about 2 high tides. So 2 high tides, 2 low tides. Please memorize that. It's about 12 hours difference between high tide and the next high tide. And just for the sake of a visual, this is what it would look like a low tide when the water recedes out. If it's a very low, shallow area, the water can go out quite far, kind of like Wasaga Beach, or if you've ever been out to the Bay of Fundy in Nova Scotia, it's quite fantastic tide there. And here you can see the water has come in. So here we're at high tide, and here we're at low tide. Now there are 2 different names for the types of tides that we will experience, aside from low tide and high tide. And that is the term spring tide and neap tide. Now, I did say that the moon has a greater gravitational effect. The sun still has some gravity pull on the Earth's water, but the moon has the greater effect. But when you can have those guys in line so that the moon is pulling on the water in the same direction that the sun is pulling on the water, then you're going to have a much higher high tide. So this bulge will be much larger when they're in line, either with the moon between, so at a new moon, or at a full moon when the moon is on the opposite side of the Earth. In either case, when they're at 180 degrees, they're in line with one another, you're going to see what we call a spring tide. Spring tide, highest high tide, and the lowest low tide that you'll get. When the moon is either at first or third quarter, as you can see in these 2 diagrams, you would then have, this would be last quarter here, You would then have them being at 90 degrees to one another. So the moon would still have the greatest influence. It would be pulling the water away from the Earth's surface on the side that the moon is on. And so you'd have a low tide here, but the sun will still have some effect, still pull a little bit. And we call this, when it's at 90 degrees, either at last quarter here or at first quarter down here, we would say that this is the neap tide. A neap tide is the lowest high tide you'll get. So the bulge is much smaller when the moon and the sun are at 90 degrees to one another. So again, a spring tide is when they are in line. You get your highest high tide and your lowest low tide. And a neap tide is when they are at 90 degrees to one another, and you get your lowest high tide, smallest bulge, and then your highest low tide. Please memorize these terms, spring tide and neap tide, and be able to identify and draw the diagrams that go along with them. Here's another way of looking at it. Here we have the Earth, and again we have the sun. And notice we have, in both cases, we put the moon in line, either on this side of the Earth or on this side of the Earth. And notice we have our highest high tide and our lowest low tide here. This would be our spring tide, and again we are in line, 180 degree line. And so you've got the combined gravitational pull of the sun and the moon pulling on the water and on the Earth. If the moon is between the sun and the Earth, when you are looking at it, you'll see the shaded part of the moon. So this would be a new moon. And as it moves around counterclockwise and gets to here, then from the perspective of people on Earth, they would see the moon fully lit. So we'd say that this is a full moon. So spring tides always occur during either a new moon or a full moon. On the other hand, the neap tides always occur when you're at 90 degrees to the sun, either up or down. And so we would say that because the people are seeing the light on the left, remember light on the left is leaving, we must be waning here. So we've gone from new all the way to full. So we've been getting brighter and brighter along the bottom here, and then we've been getting darker and darker along the top here. So we are waning, and we've gone from full moon to a waning gibbous to a third quarter light on the left. And then we will get a waning crescent and then start back again at new. When it's right at third quarter, that's when it's at 90 degrees between the moon, the Earth, and the sun. So this is when we will experience a neap tide. Same thing for down below. So we've gone third quarter back to a new moon. We've gone waxing crescent, and now we're going to hit the first quarter. And again, only half of the moon is visibly lit. And so we will say that this is our first quarter because the moon is 1/4 of the way through its cycle. Okay, so again, that would produce another neap tide, the lowest high tide that you'll have. Be sure to be able to answer these two important questions here and be able to identify or draw these diagrams and be able to know the answer for when neap tides occur and what phases of the moon are happening when spring tides occur. And that, my friends, is the end of this lesson. Please make sure you go now to our classroom online. Go to Content, Space Unit, YouTube links, and scroll down until you get to these lessons here. And please watch the spring and neap tide video. Enjoy your day.